Okay, I'm sharing my screen. Okay, so we are going to discuss the midterm set, right? If I recall, I think we finished about 14 or so. We did this inequality question. All of you have that paper, right? Just bring it up. It should say IBHL AA set1.pdf. Yeah, we finished the. Did we finish the inequality, guys? Can you recall? Can someone recap for me? Did we finish question 14 or did we not? Keshav, do you know? Or anyone actually? Oh, Keshav was not there. I thought he was. Avya, do you know if
Yeah, I think
oh,
we did finish question 14.
we finished question 14? Okay, all right. Including the inequality, right? Both the inequalities. Okay, cool. Oh, Avya, I thought you have this basketball game as well. No?
No, so my thing ended yesterday.
Oh, cool. Okay. All right. So let's start with question 15. Able to see my screen, right, guys? Yeah. Okay. Given that n is a positive integer, a and b are constants, find a and b if 1 plus ax whole power n is this, right? So binomial expansion, the expansion would be 1 plus n times ax plus n choose 2. I mean, this is n choose 1, which is, this is n choose 0, technically, times 1. N choose 2 times ax whole square. Let's do one more. N choose 3 times ax whole cubed and so on, right? Now, let's try to match up terms. So this is 1, and this is n times a times x, and this is n into n minus 1 by 2 times a square x square. So the coefficient is this guy. And then the last one, n into n minus 1 into n minus 2 by 3 factorial times a cubed. So this will be the coefficient for x cubed. Now we just have to match term by term. So the 1 matches with the 1. Okay, now minus 6 should match the NA. So let's write it out. So the NA should match my, so there are 3 variables here. There is N, there is A, and there is also A, there is also B. Okay, so NA is minus 6. Okay, that's the first one. And now 81 by 5 should match my, this guy. So N into N minus 1 by 2 times A square should match my 81 by 5. Okay, now before we go to the third one, let's use these two to solve n and a, because these two are just dependent on n and a. Therefore, it's easier to just solve them instead, right? Solve them. Now, multiple ways to solve. So one way would be I can square this first equation and divide by the second, so that a square gets cancelled. So if I square the first one, so this equation gets replaced by n square a square equal to 36. So I'll just write it here itself. N square a square equal to 36. So n square a square equal to minus 6 whole square, which is 36. Now I can divide this divided by this. So the a square gets cancelled. One of the n's gets cancelled. So one n in the numerator upon, like I said, a square gets cancelled, right? So n minus 1 into 2 equal to 36 upon 81 by 5, something like this, right? So 2n gets so this gets cancelled. This is 18. So this is 90 by 81, which is how much? 10 by 9. 9 tens are 9 nines are equal to n by n minus 1. And then visually we can see, right? Two consecutive numbers, n and n minus 1. Two consecutive numbers, 9 and 10. Therefore, we can infer n equal to 10. Now, once we unravel one, the rest become very easy from there on, right? The first equation, if you recall, this is NA equal to minus 6. And therefore, we could infer A from here. So A is minus 6 by 10, which is minus 3 by 5. Okay, and now B should be fairly easy, right? It's just substituting that. So 10 into 9 into 8 by 6 times A square, which is 9 by 25. That should match my B. So whatever that is, right? So okay, anyway, let's do it. So having come this far, might as well finish it. So 10 and then 10 goes 2 times, 5 times. I could be doing some mistakes, but just watch out, guys. 8, 72, 216 by 5. Is that what you guys get? 216 by 5. Moksha, is that what you got for B?
I got minus 25.92.
Ah, why are you scaring me like this? What is Keshav, what did you get?
It's minus 648 over 25 because it's supposed to be a cube, not a square.
Ah, okay. Then you should have called out earlier. So my mistake. Yeah. Okay, fine. Simplification mistake. But yeah, as you rightly said, a cubed, which is minus 27 by 125. So does that match with what he announced just now? What Moksha announced?
Yeah,
B.
it's the same.
It match. Okay. All right. This is a simplification, right? You guys will figure it out. Okay, cool. That was question 15. Question 16. Question 16. First part. I mean, I'm just doing it for completeness and flat practice, even though some of them might be very easy. Show that if a plus 1 by a equal to 10 by 3, this is just cross multiplication, right? If I just cross multiply, I get this quadratic, nothing to do, right? If I multiply throughout by a, I get a square plus 1 equal to 10 by 3. So you can rearrange, I get this. Hence find. Okay, so I can keep 3 power x equal to a. Therefore, 3 power minus x is 1 by a. Hence the first hint. So a plus 1 by a equal to 10 by 3. So we can solve for a from this, right? So a is minus b plus or minus square root of b square minus 4ac. So 4 into 9. So 4 into 9, just 36. So I did the subtraction. Should have, okay, whole by 2a. So it's 10 plus or minus.
So we can just simplify 10 upon 3 into 3 plus 1 upon 3.
Which one? 3.
Simplify. Yeah.
Yeah, 3 and 1 upon 3. Yes, exactly. So this is 3 and this is 1 upon 3. You could directly see that as well by simplifying 10 by 3 as 3 plus 1 by 3. Okay, so a is nothing but, so this is a, but you have to translate it back to x. So 3 power x is either 3 or 3 power x is 1 by 3. So this implies x is either 1 or x is minus 1. Okay, that was easy. Question, same thing, the B part. Question 16 B part. Thais, I don't see you. Turn on the video, please. Find an expression for y in terms of x. If log of, so this is just rearranging, right? So I can get rid of logs by saying log of 6 into x minus 3 equal to 2 log y, which is log of y square. Okay, so I can say y equal to, okay, at this point I'll say y equal to plus or minus root of 6 times x minus 3. But then I cannot have y as a negative number. If it were, then log y would not be defined. And therefore, I'll say I cannot be plus or minus. It has to be the positive root, which by definition is the simple, if you put the root sign as the positive root. So square root of 6 times x minus 3. Okay. Solve the system of equations. So this is the same equation as before, right? So we can just keep it. So 6 times x minus 3 is y square essentially. Okay, and then 2y minus x equal to 2y minus x equal to 3. So I can just substitute x instead of y. So I can just say, so x is nothing but, from the first equation, I get y square by 6 plus 3 is my x, right? So now y minus this guy, y square by 6 plus 3 equal to 3. Okay, so let's simplify this. Let's multiply throughout by 6. That's easy. So 12y minus y square minus 18 equal to 18. So y square minus 12y plus 36 equal to 0. This y minus 6 whole square is 0. Therefore, y is only 6. If y is 6, then this is 6 equal to 6 into x minus 3. Therefore, x becomes 9. Okay. So we can just do a quick check. So 2 times y is 12. 12 minus 9 is indeed 3. So this passes. This is log 6. Or check always in the original equation. Plus log of 6. 9 minus 3 is 6. Is that equal to 2 times log of y is 6? Yes, indeed. Log 6 plus log 6 is 2 times log 6. So always check in the original question. That way, if you do some silly mistake in between, all right, if you plug it in the same mistake, you'll see it'll be correct, right? You won't find your mistake. So go back to the original statement, and that way you also check whether there's any negative numbers, any violation is there with negative numbers, all of that. Okay, so that was this. Question 17. Okay, question 17. Diagram shows blah, blah, blah. The line y equal to x equal to 2c is a line of symmetry. Sketch and separate graph. Graph of 0 to 4c. Okay, so the vertical line is symmetry, right? The line of symmetry. So this is a vertical line here at x equal to 2c, which is a line of symmetry. So the graph will look exactly reflected here. So it'll be going like this till 3c. This will be 3c. And then it'll go down like this to 4c. Okay, it's symmetric, or the in the x equal to 2c. Okay, so that's the first part. Second part, y equal to f of x minus c for 2c to 4c. X minus c is what? Shift right by c. So if I take the black graph and shift it right by c, and let me draw that in blue. So this entire thing will shift right by c. So this will appear like this, and this will, right? And then the curved portion will start. So the bottom of the curved portion will be at 3c, and then the top of the curved portion will be here, right? He wants us to plot from 2c to 4c, right? Okay. So this portion I don't even need to plot, right? So I only need to plot from 2c to 4c for the second part. So sketch the graph from 2c to 4c. It'll just be the curved part alone. All of you okay on this one, right? Avya, all good so far? Pretty straightforward, right? Thais, you're okay with the question so far? Okay, on this question 18, on the same set of graphs, plot these two. Okay, y equal to x square minus 2x plus 2. So first, let's check where it hits 0, or if it hits 0 at all. So minus b plus or minus root of b square minus 4ac. No, it's negative, right? So it's always going to be above the x-axis. So discriminant is negative. So whole upon 2a. So the roots of this would be in complex numbers. Now that you have learned complex numbers, this is 4, right? Negative 4. Therefore, it's 2y by 2. So it's 1 plus or minus I. 1 plus or minus I, or I mean, he's not asking us to solve, but I'm just saying. So the roots are complex. Now, let's draw the graph. So x-axis, y-axis. The axis of symmetry will be at x equal to minus b by 2a, which is x equal to 1. Right? X equal to 1. I'll draw a vertical line. X equal to 1. Okay, x equal to 1 vertical line. And then obviously the roots do not exist. Therefore, it does not cut the x-axis anywhere. And then the graph stays always above the point. The bare minimum point is 1, comma. If I put x equal to 1, I get 1 minus 2 plus 2, which is 1. So the point is 1, comma 1. So 1, comma 1 is the lowest point. And then at the y-intercept will be in x equal to 0. When x equal to 0, this is 0 minus 0 plus 2, which is 2. So the parabola goes something like this, right? Parabola goes something like this. So that is this. Now, the reciprocal of this, I'll just do it in another color. Okay, so wherever the pink is high, the blue will be low. In fact, at this point, both will meet because this is the point 1, 1, and therefore both of them will equal. Now, as the pink is going up, this is going down, going down on all the way till 0. So as this goes to infinity, this will go down to 0. So maybe I should have picked another color since the axis is also blue. Okay, I'll pick dark blue. So this goes like this, and this is the point 0, half, because on the pink graph this was 0, 2. The reciprocal of 2 is half. So this will go down all the way like this, asymptotically approaching. So you can just say this is asymptote. X equal to 0, sorry, y equal to 0. Namely, the x-axis is the horizontal asymptote. Y equal to 0 on either side. Whereas the pink one will go to infinity. As this goes to infinity, the reciprocal will go down to 0. Okay, any doubts? All okay, right? So for Sarah, okay, Keshav, everything matches. Question 19. Question 19. The minimum value of this function is given to be blah, blah, blah. Okay, so later when you learn differentiation, you should be able to calculate this yourself, right? So that's what calculus will teach you. But in this case, he directly gives it to us, saying the minimum value is this, blah, blah, blah. Okay. State the maximal domain of f. Okay. Maximal domain means, so technically, even though a function might be defined from -infinity to +infinity, you might define it only from 3 to 7, for example, right? So over a narrow range, that's up to you. But he's asking, what is a maximum possible domain? Maximal domain means maximum possible domain. So what are the violations possible here? Only one, log of x. B is going to be greater than 0. So log of something, right? So this guy should be strictly greater than 0. Right, whatever comes in should be strictly greater than 0. So which means bx must be greater than 0. B is already given to be greater than 0. Therefore, all we need is x is greater than 0. So the domain of this is x is greater than 0. Strictly greater than 0. Log is not defined, but log 0 is not defined. Okay. Now range of f. Range of f. Now he says this is the minimum value is minus b by e. So minus a by b, sorry. So let's plot how this might look. So this is y-axis, x-axis. Okay, so it's defined only for x greater than 0. Let's understand what happens for large x. So for large x, as x approaches a zillion or a million, so this is ax will also approach a big number. Log of a million would also be a large number. So it's clear that way out here, it's going to go to positive infinity. Okay, now where will it cut the x-axis? It will cut the x-axis when ax into log of bx to the base e is 0, right? So one possibility is x being 0, but that's ruled out because we clearly said the domain is x is greater than 0. The other possibility is log of bx to be 0. So if log of bx has to be 0, that means bx has to be 1, right? So log of bx has to be 0. So which means if bx is 1, x is 1 by b. So at x equal to 1 by b, it will cut the x-axis. Okay, x equal to 1 by b. We don't know what b is. It's just some number greater than 0. And then he says it reaches a minimum value of minus a by b. So right now, we don't care where that point is. Okay, at which point it reaches this minimal value is not clear. But a and b are both positive, and the value is negative. So some negative number it reaches. So it reaches a minimum value at some point. So from there on, it's always above, right? Because as x increases, ax also increases, bx also increases, and log is an increasing function. Meaning, when you say increasing function, as the argument bx increases, the log of bx will also increase, right? Now, when x is, right, x is less than this, so what happens is, it's negative, right? By the way, from this region, it's negative. Now, as x approaches 0, just assume x approaches 0. What will the value for as x tends to 0? This will be, now this is a very interesting thing, right? As x approaches 0, right? So let's forget this problem. Let's understand the behavior of, I'll take another problem. I'll just say y equal to x times log of x. Let's understand this simple problem, right? Now, when x is, let's say, e power minus 100, right? Practically 0, right? X cannot be 0, but I'm taking a very small number. So this is almost approaching 0. E power minus 100 is 1 upon e power 100. Think of it like 1 upon 3 power 100, right? E is approximately 2.71. So it's something close to 3 power 100, you can say, right? Very tiny number. So as this happens, y will be e power minus 100 times log of e power minus 100 will be how much? Minus 100. Log of e power to the base e here. So the value is minus 100 upon e power 100. 100 is big, but not so big, right? E power 100 is huge. So 100 will get completely drowned. So this value will approach 0, right? Negative, but approaching 0. And that's exactly what's happening in this problem also, right? Instead of x, I have ax. Instead of x, I have bx. That's the only difference. They are just scale factors. Other than that, the core of it is still x times log of x. There is an additional a here, there's an additional b here. Those are just scaling factors. So it's x times log x at the core. And as we just saw with just a simple numerical example, x times log x approaches 0 as x approaches 0. X cannot be 0, but it can approach 0. It can be teasingly close to 0. So that's exactly the same behavior here also. So it'll approach 0. I'll put a hole here because it cannot touch 0, remember. The domain is x is strictly greater than 0. Therefore, the graph of this is going to look something like this. Sketch the graph. Okay, in fact, we missed the range of f, but as part of sketching, we found that also. So the range of f is minus a by be is the minimum value. He himself has told us that. So less than or equal to y, and it can go all the way till infinity, as we just established. So the range is this. Okay, all good so far on this one? Thais, make sense? Keshav, same answers, right, so far?
Yeah.
Okay. Find the coordinates of the point where f meets the, the B part. Sketch the graph giving the coordinates of the x-intercept. Did we give the x-intercept? Yeah, part 1 by b, it is 0. So this is 1 by b, comma 0. And this is something, comma, minus a by b. We don't know what that something is until we learn calculus. But this is something, comma, minus a by b. That's the minimum value. Find the coordinates of the point where the graph of f meets the straight line y equal to a times log b to the base e times x. So how will this straight line look? So this straight line looks like just a 45-degree line, right? So I'll just like a 45-degree line, something like this. And now this graph is going to intersect here somewhere. So he wants us to find this intersection point, find the coordinates. So we are going to set this equal to ax log of bx to the base e. He wants us to find the coordinates. Now a gets cancelled, and it doesn't take too long to visually see when x equal to 1, this happens. When x equal to 1, the right-hand side is, when x equal to 1, the right-hand side is 1 times log b. So the left-hand side is also that. Log b to the base e times a times 1 is same as a times 1 times log b to the base e. So in this case, it was very obvious, therefore we could solve. In general, we cannot easily solve this. We'll need a calculator to solve this. So in this case, it is very visually obvious to solve, but therefore we could say x equal to 1. And y is, as we just saw, a log b to the base e. Okay, so this intersection point. And then find the relationship between b and x at the point where the graph meets the straight line y equal to a log b to the base e. A very bad question. I don't know why. Okay, this is a log b to the base e, right? It's the same point literally. So it's the same point. A log b to the base e is literally this point. So if I draw a, so this is a flat line, right? Y equal to some is a constant. This is a constant. So that constant happens to be the same constant here. So it's just a flat line here. So now he's asking, what is the relation between b and x? What is it? Okay. What is the relation between b and x? Sorry. Okay, so yeah, it's not a bad question, right? So basically you're saying x equal to, so the blue line says y equal to x. So the blue line is y equal to x. So, and the brown line is a constant, right? A log b to the base e. Am I right? So if these two have to match, they happen at this point. I'm very confused. So we just saw x equal to 1. So yeah, I don't think he meant to ask this only, which means a log b to the base e is 1, which means there's no relationship between x and 1. So at the meeting point, x is 1. X is 1. There's no, we lose x because x is 1. We have already solved for x. Okay. What he could possibly mean is this. Okay. No, not a good question, guys. I'm sorry. Not good question. So he means a log, the very original question is ax times log of b to the base e equals a log.
So I think I got the answer to this.
How did you interpret the question to be?
I'm honestly not sure. I don't remember how I interpreted it, but what I've written down as the answer is bx equals b to the 1 upon x.
Bx equal
I-
to b to the 1 upon x.
I have no clue how I got this. I do not remember it all, but maybe it's helpful.
Yeah. So this would imply x equal to 1, like I was saying, right? We cannot infer b. We can only say x is 1 at this point.
Yeah.
Yeah. So yeah.
So I think it's just asking us to equate f and this and simplify, I guess.
Okay. So if we do that, ax times log bx equal to a log be, a log b to the base e. Let's do what you're suggesting. Okay. So we'll get a relationship. So let's see. So if we equate these two, then a gets cancelled. X times log of bx to the base e equal to log of b to the base e. So we can just write log of bx whole power 1 by x to the base e equal to log of b to the base e, which means we can just say b equal to bx times 1 by x. Yeah, I mean, you can just leave it at this point, I guess. So we can just say maybe b power 1 by b power 1 by x here, right? Equal to x power 1 by x. So we can just say b power 1 minus 1 by x equal to x power 1 by x. Something like this, but it's very obvious that x equal to 1. If x equal to 1, then you can see the right hand side is 1. B power 0 is also 1. We cannot determine b. Okay, so ignore this question, guys. Not a good question. He probably meant to ask something else, but he fumbled. Okay, that was question 19. Question 20. Find the coefficient of x power 4. It should be fairly straightforward, but still for practice, we'll do it. So x power 4 comes by a combination of this one multiplying an x power 4 here, this x multiplying an x cubed here, and this x square multiplying on x power 2 here, right? So we just have to find the coefficients of x power 2, x power 3, and x power 4 in this one. So this guy, 1 minus x whole power 9, 1 minus x whole power 9 would be 1 minus 9x, right? Plus 9. Okay. So you can treat it as either 1 minus x, or you can treat it as 1 plus minus x, either way. So the terms will alternate between positive and negative. So this will be x square, x cubed would be this. x power 4 would be, we need x power 4, and that's the last, right? 9876 by 24, 4 factorial, x power 4. Okay, now, like I said, this one, so 1 plus x square, 1 plus x square, the 1 will multiply this, and then this x will multiply this, and then this x square will multiply this. So we get x power 4 as a result of all of these products. So let's simplify this. 9 into 8 by 2 is 36. So we have 36 x square here. Sorry, x power 4 here. How many x power 4s here? 987. 7's are minus 84. Minus 84 x power 4 here. And then here we have 9 8s are 72. So this is 3. So 21 times 6, which is 126. 126 x power 4 here. So we just have to add all of them. How much is this? 126 minus 84 is 42, I believe. Therefore, it's 78 x power 4, unless I did some mistake. Same answer. Avya, did you get 78 as well?
Yes, sir.
Okay, cool. So essentially, the trick is just to separate into 3 different parts. Okay. Question 21. Sorry, guys, today is a bit monotonous, but I just wanted to do a full review of all the topics we've done so far. So just bear with me so that we just want to finish this so that we have practice on all the whole portions. Find the inverse of g of x equal to x square plus 2x plus 3. Okay, so inverse, how do you find? We just start with writing x in terms of y. So this is like your y, right? So this is y. Okay, so now we'll start with writing x equal to in terms of y. We'll say x equal to y square plus 2y plus 3. And then we'll have to solve for y. So this is a quadratic. So y square plus 2y. And think of x like a constant. So plus 3 minus x equal to 0. So the 3 minus x is like a constant. So how do you solve this quadratic? We'll just say minus b. So y equal to minus b plus or minus root of b square minus 4ac whole upon 2a. So let's simplify this. Minus 2 plus or minus, I can take 2 outside here. 4 can come out as 2. So it's 1 minus 3 minus x. So it's x minus 2, I guess. 1 minus, so when 4 comes out, it's 1 minus 3 plus x. So it's x minus 2 whole upon 2. So which is nothing but minus 1 plus or minus root of x minus 2. So this is my y. Okay, but note, he has given, find the inverse of g inverse given x is greater than or equal to minus 1. Why did he have to give this? Because this original guy was a quadratic. The quadratic was, where is the vertex for this quadratic? At minus b by 2a. Minus b by 2a is how much? Minus b by 2a is at minus 1, which means the axis of symmetry is at minus 1. So this quadratic was looking something like this. Of course, we don't know whether it's b square minus 4ac is negative. That we can quickly check. B square minus 4ac is negative, yeah, and therefore it won't touch the x-axis, but that's fine. The quadratic is looking like this. That's what matters. Now he's saying, if I have it like this full parabola, it won't have an inverse. Why won't it have an inverse? Because there are 2 different expressions for which there's a given value of y. Right? It is a function for sure, because for any given x, there's only one y. So that's the requirement of a function. But the inverse will not be a function. So to avoid that, he's saying, let's scratch off this portion. Let's consider only the portion which is greater than minus 1. So this is minus 1. So he's only considering x is greater than or equal to minus 1. So the graph of this original function is only this. Okay. Now, if x is greater than or equal to minus 1 in the original function, then in the inverse, whatever is domain for the original function will become the range for the inverse. So because if you have a function like this, let's say this is g, right? This is the input. This is the output. Right? When I do the inverse, what happens? This becomes the input and this becomes the output, right? So for g inverse, so whatever is in red is G inverse. Whatever is pink is G. So I'm using the same block to represent both. Only thing is the role of the input and output has changed, which means if the original input X is greater than or equal to -1 for the pink, then the output for the red would be Y is greater than or equal to -1. Does this make sense? This box diagram makes sense? Yeah. So Y is greater than -1, which means we should only consider the portion of root of X minus 2, which gives a value which is greater than or equal to 0. So we'll just say -1 plus root of X minus 2. Because if I considered plus or minus, that will imply that Y could be less than -1 or more than -1. We want only greater than or equal to -1 because that's the domain of G, and therefore that's the range for G inverse. So my final G inverse would be this. So this is my G inverse of X. This is a very important point, guys. Okay, so you should eliminate one of the quadratic answers. It's only one of them, -1 plus root of X minus 2. Right? And what does this tell you about the domain for this? The domain for G inverse, we can clearly see that X is greater than or equal to 2. That's the domain. Now, I'll put it here. Now let's verify whether the range for the original G was also that, right? He has not asked us that, but let's see what is the range we get for Y equal to this. So this is the function. The original G is X squared plus 2X plus 3, right? And we know the bare minimum is at X equal to -1 is the vertex. So let's put X equal to -1 and see what the value of the vertex is. It's Y equal to 1 minus 2 plus 3, which is 2. So this lowermost point is 1, 2, which means the range is Y is greater than or equal to 2. And sure enough, it matches. Just like the domain of this and the range of this matched, the domain of this and the range of this also matched. Okay, all of you clear on this one, right? How things swap, the domain, range, everything should be crystal clear. Moksh, your video is off. Okay, I have to keep observing this and saying, guys, please, you guys are taking turn to switch your videos off. I don't know why. Keep your videos off throughout the class, all of you, please. Okay, question C. Oh no, actually question B. On the same set of graphs, plot G of X as well as G inverse of X. We've already plotted G. We just have to plot G inverse, right? So let's do that in the same graph here. So the easiest way to plot is draw the line Y equal to X, the 45-degree line, and then reflect it around that. So Y equal to 45-degree line. This is Y equal to X. Okay, and then you can label the points accordingly, right? So this is -1, 2. So this is -1, 2, right? -1, 2. Therefore, the corresponding point would be 2, -1. So 2, -1 would be a point that corresponds to this. That's reflecting about Y equal to X. And this is going like this, so this will go like this, essentially. Something like this. You can see that this is getting reflected, right? You can see that this is the reflection. Okay, so it'll go asymptotically to 0, just like the pink is going not asymptotical. Sorry. So this will keep going, right? This can very much cut the axis, no problem there at all. And similarly, this can also cut and go, right? Nothing blocking it from cutting. Okay, so the reflection continues here also. Okay, you can see the complete reflection around the Y equal to X 45-degree line. All of you clear on this graphing, guys? Sorry, I didn't draw a very good graph here, but does it make sense? Thais, you're okay? Sarah, you're okay? Who's on? I cannot see. Sarah was on for some time. I don't know where she is. Okay, that was question B. Question C. Will there exist a value of G of X where G of X equal to G inverse of X? We can clearly see that there's no value because the graph does not even cut the line Y equal to X. I mean, I can visually see it, but how do I prove it? How do I prove it algebraically? So if at all I have a graph where G of X and G inverse of X intersect, that will happen. So we know that G inverse of X is a reflection. So G inverse of X and g of x are reflections around the 45-degree line, which is y equal to x. So which means if they have to match, so if they match, that means g of x and g of x will be same, and each will be same as x. They have to meet. If at all they meet, they'll be meeting at the 45-degree line where y equal to x. So if at all they meet, g of x and g inverse x will be same, and that value will be x. That value will be x. So let's solve the quadratic. Y x square plus 2x plus 3 is g of x.
So we don't need to do that. We can just look at the graph that we sketched and see that it doesn't intersect
Exactly.
the line.
I think you had switched off at that time. That's exactly what I said. And before you came back video on.
Sounds-
Yeah, no problem. I'm just saying. No, it's good observation. Exactly what I said. Intuitively, we can see that the graph does not intersect, but algebraically, I'm trying to show that that's not happening. So it's x square plus x plus 3 equal to 0. And sure enough, the b square minus 4ac for this will be negative, right? So minus 1 plus or minus 1 minus 12 is negative, which means it's not happening. We don't find an x, therefore there is no meeting point of g inverse of x and g of x. Okay. Okay, that's part C. Question 21, that was, I think. Question 20. Yeah. Okay, question 22. A function f is defined. R to R means real numbers to real numbers, right? The domain is, this is the domain, and this is the range. Real numbers to real numbers. It maps from real numbers to real numbers. F of x is 1 minus e power minus x. Sketch the graph and show that an inverse, f inverse exists. So when does an inverse exist? First of all, when does a function exist? It must pass the vertical line test. What is the vertical line test? Maybe I mentioned this term or maybe I did not. So if I have any function, right? I say this is a function. Why do I say this is a function? Because I can draw a vertical line anywhere. It only cuts at one point, meaning for any given x, there is a unique y. Okay, therefore the function exists. Now, for the inverse to exist, it must pass the inverse test. What is the inverse test? The horizontal test. I can draw a horizontal line and check if it cuts at a unique point. So clearly not. You can see in multiple cases that here maybe, right, it cuts at a unique point. But even if I give one example where a horizontal line passes through 2 points on the graph, that means when I do the inverse, it's not going to be a function because the role of x and y is going to swap. So if in the original function, 2 different x have a common y, then the inverse, it translates to 2y for a given x. For a given x, how can I have 2y? It's not a function anymore. And therefore, if any graph fails the vertical test, it's not a function. If any graph fails the horizontal test, that means further the inverse does not exist, right? So for the inverse to exist, it must pass the horizontal test. So in this case, he says, show that an inverse f inverse exists. So by sketching the graph. So let's sketch the graph. So x-axis, y-axis. Okay, 1 minus e power minus x. So let's understand what will happen. When x is very large, as x approaches, maybe you can just draft up a few values for x and you can see, right, what 1 minus e power minus x is. We know x can be from minus infinity to infinity, all real numbers. So when x is large, let's say x is 1000, then this is practically 0. 1 minus e power minus 1000 is practically 0, almost 0. Okay, so for large values, we know that the graph is going to approach 1 minus 1 minus e power minus x. E power minus x is 0. Therefore, this will approach 1. I'm sorry. So this will approach, will be approximately 1 minus, so the y value, this is the y. The y value will be approximately 1 minus 0, which is y is approximately 1. So slightly less than 1, but approaching 1. So this is the line y equal to 1. So for large values, it's going to approach like this. On the other hand, when x is 0, the y value is 1 minus 1, which is 0. So it passes through origin. It passes through origin. And then when x is a large negative value, let's say x is minus 100. then y is 1 minus e power 100. So which is a huge negative answer. So it's going to go very steeply to zero to negative infinity from here. So the graph of this function is going to look like this. I'll erase this. Right? And it's going to approach a horizontal asymptote, which is your horizontal line y equal to 1. Now this clearly passes the horizontal test. At any given point, a horizontal line cuts the graph only at one point. And therefore, since it passes the horizontal rule test, when I inverse it, it will pass the vertical rule test, which means the inverse will be a function. Inverse function exists. Thais, is this clear to you? Horizontal test and vertical test? Okay. Find the domain of f inverse and find f inverse of x. Okay. In fact, we found the domain of f inverse by saying that's nothing but the range of f. Now, range of f is what? So this is f, and let's say this is domain and this is range. Okay. So the domain for f was given to be all real numbers, minus infinity to infinity. And the range also, we just saw by the red graph, the y value could go all the way from minus infinity and approaching 1. It will never reach 1, it will approach 1. Now, for f inverse, it must be exactly the opposite. For f inverse, we expect this to be the domain. So we expect minus infinity less than x less than 1 to be the domain. And then we expect this to be the range. We expect minus infinity less than y less than infinity to be the range. Let's check that, right? So let's find the inverse and just check if that comes out to be the case. Okay, so this is, let's find the inverse. So y equal to 1 minus e power minus x. So we'll first swap x and y to find the inverse, right? So, which means, I mean, this is just a swapping step, right? Swapping step to find the inverse. And then how do I solve for y in terms of x? X minus 1 equal to minus e power minus y. I'll continue here. So e power minus y is 1 minus x. Now we can take ln on both sides. Ln of 1 minus x is minus y. Therefore, y is minus ln of 1 minus x. Okay. Now, if we have minus ln of 1 minus x, for ln to be defined, the argument that is inside ln should be strictly greater than 0, which means we want 1 minus x should be strictly greater than 0, which means if I move the x to this side and move the right, and it's just 1 is greater than x, which is nothing but x is less than 1, which is exactly what we're seeing here. X is less than 1. X can be all the way till minus infinity, but on the higher side, it has to be maximum 1, cannot reach 1. X is less than 1. So that matches with the domain here. And what is the range? Range of minus ln of 1 minus x. We can see, right? ln itself can go all the way from minus infinity to infinity. Therefore, ln of something will go all the way from minus infinity to infinity. And with the negative sign here, we can say it goes from plus infinity to minus infinity. So the range is clearly the minus infinity to plus infinity as expected here. Okay, so we found the function. The function is minus ln 1 minus x. And then we found the domain of f inverse. We just said the domain is minus infinity less than x less than 1, as we just said here. Okay, sketch the graph of f inverse on the same graph. So here, so the line y equal to x will pass. You can see that the line 45-degree line y equal to x will be here, right? So clearly it passes through origin. So origin will be a point where f and f inverse will meet. And beyond that, it's just a reflection. So just like the horizontal asymptote, maybe I'll just draw a separate graph. So it's too confusing here. Just take a fresh graph. It's axis, y-axis. Okay. The original graph was like this. Approaching y equal to 1 and approaching negative infinity like this and passing through 0, 0. Now we'll draw the line y equal to x here, 45-degree line. passing through origin. Okay. Didn't come out well. But a very line. So it passes through origin, and therefore the reflection of this will also pass through origin. The reflection will look something like this. And this will approach the vertical line. Which will be essentially the symmetric, the opposite of the horizontal line. So the horizontal line was y equal to 1. That was asymptote here. On the flipped side, the vertical line, so the vertical line that I just drew here, so which is x equal to 1, will be the vertical asymptote. And then this graph will go like this. This will approach just like, because the reflection of this is like this, right? The 45-degree line goes like this, so it will be reflected like this. And we can just check, right? So this is the one minus ln of 1 minus x. So the vertical asymptote is at, I'm not drawing the graph very clearly here, but the vertical asymptote is x equal to 1 is very clear, right? Because it cannot approach 1, as we just, it can approach 1, but it cannot reach 1. Right? And on the other side, x can be as low as minus infinity, and then gradually this will go up, approaching minus infinity. Okay, the graphing is clear, I assume. Okay, that was question 22, 23. Arithmetic progression, geometric progression, I believe. Let me just create more space here. All okay, guys, today? Very quiet. I've also not been asking questions, but it's more like a review, right? So I didn't want to ask too many questions also. But can I take a pause? All of you okay? Avya, any doubts so far? Matching, you've done the full exercise, right? And so far answers are matching?
Yes, sir.
Okay, cool. In the sequence 2, 2.5, 3, 3.5, what term will be 96p? That's easy. A plus n minus 1 times d. D is half. So it will be 49.5. Okay, in a city, there was an average crime rate of every 90 minutes. Oh, yeah, I think this Keshav, I think you were asking me this question offline. Crime rate every 90 minutes. So it's one crime per 90 minutes. Or rather, 1 by 90 crimes per minute. Right? You can read it as 1 crime per 90 minutes or 1 by 90 crimes per minute. Okay. Now, this represented an increase of 10% over the previous year. So previous year, current year. So when he says this is the rate he's talking about, right? He's talking about the crime rate. So the crime rate, the current rate is 1 by 90. In we are measuring crime rate in crimes per minute. In crimes per minute units, last year was something. Now this year, it's a 10% increase. Right? So after the 10% increase, it became 1 by 90. So, I should not say X here. This is the rate here, right? I'll just say R for rate. Okay. So in other words, the rate R last time times your 1.1 or 10% higher, right? 1.1 has now become 1 by 90, which means R is 1 by 1.1 times 90 is 99. So which means this R was 1 crime per 99 minutes. So in the previous year, there was an average crime every X minutes. Find X. X is 99. Yeah. Was this Keshav? You were asking this question, if I recall, right? If Keshav is still around.
Yeah, but I figured it out.
Okay. All right. Same answer, right? X equal to 99.
Yeah, 99.
Okay. Cool. Given, find X given 3 minus 6 plus 12 minus. This is just a geometric progression sum. So geometric progression, the sum till n terms is a times r power n minus 1 by r minus 1. Or you can say a times 1 minus r power n upon 1 minus r. Both are equivalent. Typically, in this case, r is numerically bigger than 1, right? So I try to keep r power n minus 1. So in this case, a is 3, r is minus 2. So it's minus 2 power n minus 1 upon minus 2 minus 1. So minus 3 equal to minus 63. So this is 3 and 3, and then minus and minus gets cancelled. So 2 minus 2 power n is 63 plus 1, which is 64. So n must be an even number, and sure enough, 2 power 6 is minus 2 power 6, n equal to 6. So n equal to 6, the number of terms is 6. We have still not solved the problem. He's asking what is the last term, right? Essentially, so the last term is 3 times minus 2 power n minus 1. So 3 times minus 2 power 5. So which is minus 32 times 3. So x is minus 96. So, and we don't even need so much math. We can, since it's a small number, we can just check it also. 3 minus 6 plus 12 minus 24 plus 48 minus 96 will end up being minus 63. So this is minus 48. This is minus 12. And this is minus 3. They add up to minus 63. Okay, easy question. Next one. A series is defined as log 3 plus log 3 square plus log 3 power 4 and so on. 3 cubed and so on. What is the smallest number such that Sn is greater than 1000? Okay, so log, so this becomes log of to the base 2, 3 into 3 square into 3 power 3 into 3 power 4 and so on, right? Okay, so it becomes log of 2, 3 power 1 plus 2 plus 3 so on till n. Smallest value of n. He says n terms. I mean, he didn't say what n is, but he means n terms. So this must be greater than 1000. This must be greater than 1000. So Sn is greater than 1000, right? So I think we are allowed to use. Okay, sorry. This is okay. You can either treat it as an arithmetic progression or a geometric progression. Let's treat it as an arithmetic progression now. So this is log 3. So this is log 3 to the base 2 plus 2 times log 3 to the base 2 plus 3 times log 3 to the base 2.
So we were allowed to use a calculator for this, right?
Yeah, we should be allowed to use calculator. Okay, log 3 to the base 2 and so on, right? So this is log 3 to the base 2 times 1 plus 2 plus 3 so on till n. Okay, so I mean same as this. I can bring 1 plus 2 plus 3 so on to this side also. It's essentially same thing. So this must exceed 1000. Now, yeah, you're allowed a calculator, but in case you're not allowed a calculator, I mean, you cannot not be allowed. You should be allowed for this. Yeah. So log 3 to the base 2 will be how much? Approximately, it'll be around 1.6, I guess. 1.6 approximately. So 1.6 times this should exceed 1000. So which means this must be approximately exceeding 600 and let's say 600 approximately. So which means I'm just doing it very approximately. You guys can do it on your calculator. N into n plus 1 by 2 must exceed 600. That most n must be approximately around 24 or 25 depending on what you should get an answer. No, sorry, n into n plus 1 should be, I forgot the divide by 2. So n into n plus 1 should exceed 1200. Therefore, n must be somewhere close to 35 or something like that. What is the number that you got, Moksh, on calculator?
I got 36.
36. Yeah, it should be around thereabouts, 35 or 36. But with the calculator, you will find that. But always be careful whether it's strictly greater than or equal to. In this case, I don't think the equal to will be reached. It'll either be before or after. But some cases, if it just exactly matches, be very careful about the equality sign there. Okay. Question 24. Complex numbers. Okay. Okay, this is at least a new topic. So far, all the topics you have seen in the past or something that you have done already. So complex numbers are probably new, right? So given W is blah, 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 what is modulus of W? Modulus of W is, you can, if W is, for example, if W is ratio of two complex numbers, Z upon or Z1 upon Z2, then mod of W is same as mod of Z1 by mod of Z2. So it'll just be mod of 3 minus 2y by mod of minus 1 plus I. So this will be square root of 3 square plus 2 square. It will be square root of minus 1 square plus 1 square. So root of 13 by 2 like this. So that's this argument of W star. Okay. So argument of W star. Okay. On the calculator, you can do this 3 minus 2y. So argument of W would be argument of Z1 minus argument of Z2. Now, some of them will be able to do without calculator. Some will need a calculator. So on this one, argument of the denominator is easy. Minus 1 plus I. Let's draw the graph and see where minus 1 plus I falls. Minus 1 plus I will be minus 1 plus I will be somewhere here. So the argument of Z2, so this is my Z2, the denominator, is 135 degree or 3 pi by 4. 3 pi by 4 is the argument. Sorry? The voice was breaking up. Please repeat.
Nothing.
Oh, okay. All right. But argument of the numerator is not obvious. So therefore, I'll have to resort to calculator. A minus 2 plus 3 would be somewhere here, right? Minus 2 plus 3 would be somewhere here. So that'll come to some argument. And we have to subtract the two arguments on a calculator. So it'll be a positive number. Why? Because the denominator would be 135 degrees. So this is 135 degrees. The numerator would be...
Sir, I forgot, why are we subtracting again?
Because we are finding the argument. Okay. The difference of the two arguments is the argument of the ratio, right? Argument of W is argument of Z1 minus argument of Z2.
Okay.
Okay.
Got it.
But I made a mistake in plotting, and none of you spotted it also. It's 3 comma minus 2, right? So 3 comma minus 2 will be somewhere in the fourth quadrant. So Z2 is here. 3 comma minus 2 would be somewhere here. 3 comma minus 2 would be somewhere here. So this will be Z1, the numerator. So the argument will be something like, I don't know, minus 30 degrees maybe. I'm just making up some number. So this will be minus 30 degrees minus 130, not 30 exactly. Yeah? Let's say 32, just so that you guys are not wrongly assuming. In fact, on the calculator, can we just quickly do? So tan inverse of 2 by 3, right? Tan inverse of 2 by 3, because this is 3 and this is 2, 3 comma minus 2. Can you guys do it quickly? Tan inverse of 2 by 3 kitna hai? Can someone tell me on the calculator? Keshav, I cannot see your face. Can you change your move your laptop, tilt your laptop?
So 33.7.
33.7. Okay, I was close. So it's minus 33 in this case. Minus 33.7. And then the argument of the denominator, we all agreed, was minus 135. Therefore, net will be minus 168.7 or close to minus 180. Now, let's check whether we get the same answer by actually dividing it. By actually dividing it, we should expect a complex number which is almost close to -1. Do we see that? Let's see. Let's do the division. How do we do the division? By multiplying and dividing by the conjugate. So the conjugate of minus 1 plus I is minus 1 minus I. So I'll multiply numerator and denominator by minus 1 minus I. So the denominator will be minus 1 square minus I square, right? So will become minus 1 square plus 1 square, which is 2. And the numerator, let's multiply. So 3 minus 1 is minus 3. Minus 2i times minus I is 2i square, which is minus 2. And then minus 2i times minus 1, and then 3i times 3 times minus I. So net we have minus 5 minus I by 2. So where will this complex number be? This complex number will be minus 5 minus I. So it will be something like this. And sure enough, we do see that this angle is close to minus 5 minus on the third quadrant, right? Third quadrant. So I'll draw the number line again. Minus 5 minus 1. Minus 5 minus 1 will be this. And sure enough, this angle matches what we expect. Minus 168.7. So it's good to see that both the polar form and the Cartesian form are giving consistent results. Okay, and then let's check the argument of this and also see whether it matches. So argument of this would be 5 by 2 whole square plus 1 by 2 whole square root of that. So this will be square root of 25 plus 1 by 4. So square root of 26 by 4, which is square root of 13 by 2, which matches with what we got earlier. If you remember, we got the argument is the modulus is my square root of 13 by 2. Okay, all good so far? Okay, so W star will be the exact conjugate of this. We just saw W was minus 5 minus I by 2. Therefore, it will be minus 5 plus I by 2. That's W star. Okay, and imaginary part of W is your minus I by 2. Minus 5 minus I by 2, right? Therefore, it's minus I by 2. Sometimes people ignore the I. They just say minus half. They'll assume the imaginary part includes an I built in it. So the conventions might vary. So if your school enforces to say including the I, just say that. So minus I by 2 is technically the imaginary part. Okay, all good? Thais, Sarah, so far all okay?
Sorry, I don't understand the last one about the imaginary part.
Oh, when I have any complex number, suppose I have 2 plus 5i. Okay, so this is the real part. And this is the imaginary part. Right? The
Oh,
portion,
okay, yeah, sorry, I was confused for a second.
yeah, IM stands for imaginary part. And RE stands for the real part. So they could ask RE of W. That means the real part of W, which is minus 5 by 2 in this case. Okay, that is 24, 25. In a GP, the sum of the first 3 terms equals, okay, let me ask someone here. Avya, what did you get on this one? For question 25A, if you have your working.
I can't find it.
Okay. What about Moksh? Were you able to find it? What is the common ratio or
25, right?
25A?
1 upon 2.
1 upon 2. Anyone, Keshav? 1 upon 2 for you as well?
Yeah, I put 1 upon 8 is equal to R cubed. So I think 1 upon 2 I got.
1 upon 2. Okay. Let's verify. In unified GP, the sum of first 3 terms. So A into 1 plus R square. That's the sum of the first 3 terms equal to the sum equal to 7/8 of the sum till infinity. A by 1 minus R. Okay. So A gets cancelled. And then I can cross multiply 8 times 1 minus R times 1 plus R square equal to 7. Right? 8 times, this is nothing but 1 minus R cubed equal to 7. So 1 minus R cubed equal to 7 by 8. Therefore, 1 by 8 equal to R cubed, like you said. And therefore, R is half. There's no complex numbers in this at all, right? Just simple, plain. R equal to half. Okay. Plant is 50 centimeter high. Okay. This one, Thais, did you do this one? 1 week later, it's going to 10.
No, I
Thereafter.
couldn't do it.
Why not?
I was a bit confused about that part.
Why? I mean, it seems fairly straightforward. Plant is, okay, let's see. 50 centimeter high when it's first observed. 1 week later, so this is week. Okay. And this is the height. Okay. So starting off at time 0, the height is 50. And then 1 week later, the height is 60. And thereafter, it goes to 60% of the previous. So week 2, it will be 60 plus 60 times 0.8. It grows 80% of the previous week's growth. So the previous week's growth is 60 times 0.8. Therefore, in the third week, it will be a further 0.8 of that. Does this make sense, Thais? Yeah. What will the plant's ultimate height be? At infinity, he's asking what will the height be. So in other words, at infinity, the height would be, so 60 plus 60 times 0.8 plus 60 times 0.8 whole square and so on. So this is just sum till infinity of a geometric progression, which is 60 by A by 1 minus R. So 60 by 1 minus 60 by 1 minus 0.8, 60 by 0.2, which is 300. Okay, Sarah, if Sarah around, you get the same answer, 300.
I didn't get the correct answer. I think I messed up. So I got the same pattern, 60 plus 60 into 0.8. I don't know why I didn't get the same answer, but I
Yeah,
got,
it's just a by 1 minus r, right? There's not
yeah,
much of scope of making mistake here.
yeah.
Okay. That is 25, 26. Some trigonometry for a change. 1 minus cos 2a by 1 plus cos 2a. Okay, so we know all the double angle related to cos 2 theta, right? So just to recap, cos 2 theta was cos square theta minus sin square theta. Okay, and then you could replace the cos square theta as 1 minus sin square theta. Therefore, you get 1 minus 2 sin square theta. On the other hand, you can replace sin square theta as 1 minus cos square theta. Therefore, you get 2 cos square theta minus 1. So all three formula are used, right? So let's use whatever is. So when I have 1 minus cos 2a, it's easier to use this guy. So I'll say this is 1 minus 2 sin square. Therefore, will be 2 sin square a. And for 1 plus cos 2a, just so that the 1 knocks off, I'll use this one. So it's 1 plus 2 cos square theta minus 1. Therefore, it'll just become 2 sin square theta. So 2 cos square theta, sorry, 2 cos square theta. So 2 cos square theta, cos square a, whatever. And therefore, we have proved it to be tan square a, as simple as that. Go to RHS. Okay, straightforward, right? Solve the equation 2 sec square theta plus tan theta minus 3 equal to 0. So let's try to convert it into quadratic because sec square theta is 1 plus tan square theta. So plus tan theta minus 3 equal to 0. So we can say let tan theta be equal to x. Okay, therefore have 2x square plus tan theta, which is x, and then plus 2 minus 3, which is minus 1. Therefore, x is minus b plus or minus square root of b square minus 4ac. 4ac is 8 whole upon 2a, which is 4. So it's minus 1 plus or minus 3 by 4. So minus 1 minus 3 upon 4 would be minus 1. Or minus 1 plus 3 upon 4 would be half. Okay, so he says 0 to 180. So 0 to 180, tan is positive here and tan is negative here. So for technically for half, we'll have two answers, right? When tan theta equal to half, it will be either this value or this value. The value in the third quadrant is not applicable here. So this is first, this is second, this is third, this is fourth. So we'll take this value, tan inverse of half. We cannot take this value because it's 0 to 180. Similarly, for tan theta equal to minus 1, it's either the minus 45 degree line here or in the fourth quadrant. It's negative in the second and the fourth quadrant. But I'll only be able to take this, not here. So, and this second part is easy. So theta is 135 degree. Tan 135 is same as tan 45 with a flipped sign. So minus 1. And this one, you'll need a calculator, tan inverse of half. Okay, Keshav, same answer on this one.
Yes.
Okay. Find the exact value. Sarah, what did you get for the C part? Exact value of tan 105 plus tan 15.
I didn't solve this question.
Okay. Why is that whoever I'm asking, they have not solved that particular question? I mean, they are all fairly straightforward, looks like, right?
When I
Okay.
saw A, I thought I won't be able to do this, so then I didn't do it.
Okay. They're all unrelated questions, right? So, but anyway, let's do it now. So I'll use tan of A plus B. So recall tan of A plus B is tan A plus tan B, tan A plus tan B by 1 minus tan A tan B. Okay. And if I have tan of A minus B, everywhere the sign gets flipped. Tan of A minus B is tan A plus tan B by blah, blah, blah. So here I'll use tan of 60 plus 45. Right. So tan of 60 plus 45 is tan of 105. So it's tan 60, which is root 3, plus tan 45, which is 1, upon 1 minus root 3 times 1. So that's this. And the other one is tan of 60 minus 45. So it'll be root 3 minus 1 upon 1 plus tan A tan B, 1 plus root 3. So we just have to add both. Okay. Just have to add both. So root 3 plus 1 by 1 minus root 3 plus root 3 minus 1 by 1 plus root 3. So let's take the common denominator by multiplying 1 minus root 3 and 1 plus root 3, I get 1 minus 3. And in the numerator, I get root 3 plus 1 square. Okay. And then here I get minus root 3 minus 1 whole square. Because this is 1 minus root 3, this is root 3 minus 1. So this becomes a plus b whole square minus a minus b whole square. So it just becomes 4ab because the a square plus b square gets cancelled. So it becomes 4 root 3 here. Okay, and the denominator becomes minus 2. So it's just minus 2 root 3. Sarah, does this make sense? Yeah, fairly doable, right?
Yeah.
You need
really.
not have skipped it. Okay, so Keshav just rejoined. Did you get minus 2 root 3 Keshav on the C part? On tan,
What? Oh,
tan
no,
105.
I made some addition mistake, but yeah, I
Okay,
yeah, I got it.
you found your mistake though. Okay. Or but that's pretty much what you did, right? 60 plus
Yeah,
45
I
and
did
60
60
minus
plus
45.
45, 67. Yeah, that's right.
Yeah, just 1 second, guys. I'll just get some water. Okay, I'm back. That was question 26. Question 27, induction. Okay, just quick practice on induction. Okay, so the first step in induction, just to recall, was just verify that it's true for n equal to 1. So for n equal to 1, we just have to verify. So LHS is just 1 by 2 factorial, because we go till n equal to 1, right? So 1 by 2 factorial, which is 1 by 2. And RHS is 1 minus 1 by 1 plus 1 factorial. So it's 1 minus half, which is half. Therefore, n equal to 1, it matches. Now we'll just assume n equal to k is true. Okay, so what does that mean? So we'll assume that 1 by 2 factorial plus 2 by 3 factorial plus all the way till k by k plus 1 factorial. We'll assume it to be equal to 1 minus 1 by k plus 1 factorial. That's the assumption step. Assume. Okay, and now comes the hard step, right? Now we have to prove for n equal to k plus 1. We have to prove n equal to k plus 1 is true. Okay, so the LHS for that would be all the way till whatever we got in the previous step, plus an additional term, right? So it'll be all the way here, plus k plus 1 by k plus 2 factorial. Okay, so that's what the LHS would be. And always, like I said, keep an eye on what your destination is. You want somehow, so our destination here, I'll just put a destination. We want to have 1 minus 1 by k plus 2 factorial. So we should do whatever we do to get there somehow. Okay, so what do we have so far? So this is what our goal is. We'll keep an eye on this. Oh, where did I lose this now? Why am I not able to write on this? Just 1 sec. One sec. I just have to modify my document to be able to write. Uh, okay, something happened. I'm struggling here. Okay, fine. I'll just continue on a new one. Uh, I'm reopening my notes. Sorry, guys. Sorry about this. Okay, I'm back on track. Are you able to see this? This thing, white page? Can someone confirm?
Yeah.
Okay, cool. Okay, so we had our destination was 1 minus 1 by k plus 2 factorial. Okay, now when we started the third step, we said the LHS included all the way till the first few terms from the k plus 1 from the k assumption step, which added up to 1 minus 1 by k plus 1 factorial. The only additional term that we had was k plus 1 by k plus 2 factorial.
Wait, so we can see the worksheet, but we can't see if you're writing anything.
Why so? Oh, I'm sharing this one instead. Okay. Okay. Sorry. Now?
Yeah, now we can see.
Okay. Yeah. The destination was 1 minus 1 by k plus 2 factorial. And then we said from the assumption step, the first several terms added up to 1 minus k plus 1 factorial from the previous step. And then the additional term that we have is just k plus 2 1 by k plus 2 factorial. Now, we know that we need a 1 here, and we have a 1 here already. So we won't disturb that. So we'll just simplify the other two terms and hope we'll get 1 by k plus 2 factorial. So if I take these two terms, what is the common denominator? K plus 2 factorial. We have k plus 2 factorial as the common denominator. Here it's just k plus 1. So k plus 2 factorial is k plus 1 factorial times another k plus 2, right? So here it is. So this one I'm not even disturbing. So it's minus of k plus 2. So this just becomes minus 1 in the numerator, right? Minus k will cancel off with the plus k. So leaving minus 1. So it's 1 minus 1 by k plus 2 factorial, which is exactly what we want on the RHS, and hence proved. Yeah. Fairly straightforward induction question. Okay. Trigonometry, prove that sine 2x by 1 plus cos 2x. Okay, so sine 2x is sine 2 theta. So LHS is, okay, I'll just do it. LHS is sine 2 theta is nothing but 2 sine theta cos theta. So 2 sine x cos x. And then 1 plus cos 2x, you remember, one of those formulas was 2 cos square x. So it's very easily simplifies to sin x by cos x, which is tan x. Easy. I can convert it into a quadratic. So 1 minus sine square theta plus sine theta equal to 1. So let's say sine theta equal to x. Let's say sine theta equal to x. Then I have minus 2x square plus x plus 2 minus 1 equal to this. So x equal to minus b plus or minus root of b square minus 4ac whole upon 2a. So it's minus 1 plus or minus 3 upon 4. Minus 4, sorry. Minus 1 minus 3 upon minus 4 will become plus 1. And then the other one is 2 upon minus 4, which is minus half. So 1 or minus half. Now from 0 to 2 pi. So sine theta is 1 at x equal to pi by 2. So one answer is, sorry, not theta. Theta is equal to pi by 2, x equal to 1. So x equal to 1 corresponds to theta equal to pi by 2. And x equal to minus half. So when is it plus half? It's at 30 degrees. 30 degree, 150, 210, and 330. So are your 4 numbers which are equivalent, right? Only thing that will differ is the signage. So this is pi by 6. This is 5 pi by 6. This is 7 pi by 6. And this is 330, which is 11 pi by 6. Now, when is it positive? When is negative? Sign is positive here, here. It's negative here and here. So negative half would correspond to the 2 answers here. 7 pi by 6 or 11 pi by 6. Okay. Keshav, same answer on this one?
Yeah.
Okay. We just have a few more questions to complete. Let's see. Prove by induction n cube minus n is divisible. I think that's fairly straightforward. I can skip that one, right? It's fairly straightforward. You'll see it for yourself. I'm going to skip that one. Unless someone wants to prove, someone wants me to discuss. Thais, did you try this induction question 29? Prove by induction? Did you
Yes,
get
sir,
that
yes,
one?
I did, yeah.
Okay. So we can skip that and go to question 30, complex numbers. Find the square root of minus 7 plus 24i. So I can use it. I can just 1 second. Huh? Have minus 7 plus 24i. So I'll just say let the square root be x plus iy. So x plus iy whole square is minus 7 plus 24i. So when I square this, I get x square plus 2xyi and then plus y square I square, which will be minus y square equal to minus 7 plus 24i. So which means I need to find 2 numbers x and y such that x square minus y square is minus 7 and 2xy should be equal to 24. And then we can easily guess those numbers here itself, right? So x into y is 12. So we can guess that x equal to 3 and y equal to 4. So 3 square minus 4 square is minus 7. Or x equal to minus 3 and y equal to minus 4. Okay, if you cannot guess, you can just solve it using quadratic. So there are 2 answers. So there are 2 answers for the square root. 3 plus 4i and minus 3 minus 4i, minus of 3 plus 4i. So for complex numbers, we cannot say this is the positive root and therefore only root and all that. There are 2 square roots. So 3 plus 4i and minus of 3 plus 4i. Okay, simplify. So this is cis 9 theta. And this is cis of minus 15 theta. So cis works like your log pretty much, right? Upon cis of minus 8 theta. So this is cis works like e power, sorry. So cis of 9 theta minus, so this is minus 6 of minus 6 theta by cis of minus 8 theta, which is cis of 2 theta. Okay, that's clear. Question 30b. Show that z power n plus z power minus n is 2 cos n theta. So z is where z is a complex number, right? So z is r cis theta, right? So z power n would be r power n cis n theta. Okay, So z power minus n would be r power minus n cis minus n theta, right? So he's making a mistake. It won't be true for any complex number. It'll be true for a complex number where r is 1. So he's assuming r is 1, where r is 1. Because only then this will be cis n theta. So let's see what we get. So if we get z power n plus z power n plus z power minus n, if r is 1, if r is 1. So if r is 1, if r is 1, then we get z power n plus z power minus n would be cis n theta plus cis minus n theta. So this will be cos n theta plus I sin n theta. Okay, and this will be cos minus n theta plus I sin minus n theta. Okay, cos is an even function, therefore this will be same as cos n theta. Sin is an odd function, therefore this will become minus sin n theta. So the minus and plus will cancel for the sin theta. So leaving just 2 cos n theta. Okay, but he's missing this point. If z is a complex number where r equal to 1, otherwise it won't be 2 cos n theta. Okay, solve the equation 3z power 4. He is using the word hence, so we can use this previous relation. Okay, so I can divide throughout by, I somehow want z power n plus z power minus n, right? I'll divide throughout by z square. So that way it becomes 3z square and this becomes 3z power minus 2. So these two can be combined using the previous relation. This becomes 2z and this becomes 2 upon 1 by z, or 2z power minus 1. So these two can be combined as well using the same result, right? So we get, by combining the 3 times z square plus z power minus 2 using this relation, is 2 times cos n is 2 here, 2 theta. And then 2z plus 2z power minus 1, z power 1 plus z power minus 1 is 2 cos 1 theta. And then plus 1 equal to 0. Okay, so now we can solve for this. So we get 6 times cos 2 theta plus 4 cos theta plus 1 equal to 0. I can convert cos 2 theta as 2 cos square theta minus 1 using what we saw earlier. So plus 4 cos theta plus 1 equal to 0. Therefore, we get a quadratic 12 cos square theta plus 4 cos theta minus 6 plus 1. So it's minus 5 equal to 0. And now I can use quadratic formula to solve this. Let's see. So we get cos theta is minus b plus or minus root of b square minus 4.
You can just factor as 10 and minus 6, right?
You can factorize, yeah, 10 and minus 6, exactly, 10 and minus 6. But having come this far, I'll just do it. B square minus 4ac, 420, 240, 250. 240, sorry, 240 whole upon 2a, which is 24. So it's minus 4 plus or minus 16 upon 24. Yes, factorization would have worked much faster. So cos theta is either half or minus 5 by 6. All right, and this is cos theta, and then therefore we'll say z is cis theta, right? So cos theta plus I sin theta. So we'll have 4 answers, right? Because cos theta is half. If cos theta is half, so this is cos theta, so this is sin theta. So if cos theta is half, sin theta can be plus or minus root of 1 minus cos theta, right? And similarly, if cos theta is minus 5 by 6, sin theta is plus or minus root of 1 minus cos square theta. So it'll be 1 minus 25 by 36, so 11 by 36. So you get 4 combinations here. So z is nothing but cis theta, right? So you should write, you're asking to solve for z, which is a 4th order equation. Therefore, we expect 4 roots. Half plus root 3 by 2i, half minus root 3 by 2i, minus 5 by 6 plus root 11i by 36, root 11i by 6 after. and minus 5 by 6 minus root 11 I by 6. So those will be the 4 answers for Z. Okay, I think we are over time. We almost finished. I think we just have few more questions. So let's, I mean, it's not too few also. So we have 5 more questions. Let's do it tomorrow. Let's do it tomorrow, and then we'll do the rest of the probability questions, and then we'll wrap for tomorrow. And meanwhile, if you guys have not voted on what the plan for the next several weeks is, just please vote. I saw some of you prefer to complete it by mid-September. Some of you prefer to take a break and then resume later. So whatever it is, please vote. Okay, and then we'll go with that. Okay, see you tomorrow then. Bye.
Is it completion by November 15th, or are we
No.
starting by?
We're starting by November 17th. And then it'll be for 3 weeks after that. We have 3 more classes after this weekend. We have 3 more weekends left. So those 3 more weekends is the question is either do we finish it now or do we resume November 17th, therefore 17th, 24th, 30th, something like that. Those 3 weekends.
Okay. Cool.
Okay, bye. See you guys.